Everyone keeps asking me what model can I run on my device, and I think it's time for you guys to stop asking me because there are two free tools that answer that question for you in minutes. One does math, the other uses real data, and neither one is completely trustworthy, to be honest. I tested both, and let me save you the headache what these will do for you. My name is Daniel Jindu, and I used to run AI info business that questions my moral every single day, and eventually I had to quit. Now I'm just giving away everything I know about AI for completely free. There's no gatekeeping. You can join my community for free. Newsletter to get as much as value you can. You can just take it all I'm asking for is maybe consider commenting on this video to help me keep going, but it's not that necessary. It's up to you. Okay, so let's think of it like this. You're on a beach with buried treasure somewhere in the sand. Right now, most of you are just digging random holes. You download a model that's 40 gigabytes, wait 20 minutes, and it crashes on you. You try another one, same thing, or worse, you go buy a new computer based on a guess, and it still can't run what you need. That's a $5,000 hole in the wrong spot. The question is very simple. What can my machine actually run? And two free tools try to answer that, but they work in completely different ways, and both of them have traps that you need to know about. First tool, LLM Fit. Let's think of it like a metal detector here. You wave it over the beach, it scans what's underneath, and it beeps something's here, probably Fit. In plain English, LLM Fit is a free tool that scans your computer, reads your RAM, your GPU, your VRAM, and then scores a list of AI models on whether they will fit in your hardware. It does this with math, which is pretty cool, right? And for that specific job, will this model physically fit in my memory? It's a very solid starting point. I think it's very fast, right? So you get a ranked list in a couple minutes. It has a hardware simulation mode where you can punch in specs for a machine you haven't bought yet and see what would fit actually. That's a real feature for anyone comparing laptops or GPUs before spending any money, right? Now the catch here though is the metal detector beeps, but it cannot really tell you what's actually buried under there. The speed numbers LLM Fit gives you are not real. They are just estimate based on formulas. Tokens per second is just a speed measurement. More tokens, faster responses. And LLM Fit's estimates are routinely 3 to 10 times higher than what you will actually get. One user reported that LLM Fit predicted 130 tokens per second. In reality, it was 30 tokens per second, which is a huge difference night and day. Yeah, and that's not a rounding error. It's literally a fantasy number, right? And it gets worse. There's a specific type of model called mixture of experts. In plain English, it's a model built from multiple smaller models working together. It sounds very efficient, but it uses way more memory than the name suggests. And LLM Fit's math breaks on these. There's a documented case where it scored a 70 gigabyte model as a perfect fit on a machine with 33 gigs of memory. Perfect fit, it would crash immediately. So it also recommends model based on whether they fit, not whether they are any good. Fit and quality are just two different freaking things. So don't just download whatever it ranks first. My take on LLM Fit though is this. I think it's a very useful metal detector. It's better than nothing at all, right? It gets you the short list that you're looking for, and just ignore the speed numbers. And if you see mixture of experts in the model name, you can just double check the memory requirement by yourself. So the metal detector gives you a starting point, beeps in the right general area. But what if instead of math, you could just read a logbook from other people who already dug in this exact spot on this exact beach? Contingent, they never took the thing out and took it home. Second tool is WhatCanI.Run. This one takes the opposite approach, which instead of estimating, it collects real data, real speed numbers from real people running real models on real hardware. And it works in two ways here. First way, which is you don't install anything at all. You just go to the website, pick your device from a drop-down, and browse there. If you have M1 Max with 64 gigs of RAM, you can see exactly how fast Llama 3 or whatever, Qwen 3, 1.7 billion parameters or 9 billion parameters runs on that chip. Measured by someone who owns the same exact machine, tokens per second, memory usage, time to first token, real numbers. That's the data you cannot really get from LLM Fit. It's the real data-driven numbers. Second way, which is you contribute on it. You run a single command in your terminal, which is bunx, what can I run, which runs it without installing anything permanently It's just pointed at a model and it benchmarks that model on your machine using a standardized test. First, it downloads that model for you from Hugging Face if you don't have it yet. Then it submits your result to the database so the next person with your hardware can see what you got from there. The concept is, I think, better because real data beats guesswork always when the data is there. And the catch here is this. It's mostly not there. What that means is about 190 people have contributed results so far. Total of 190 people, 4,400 trials across all of them. The data set is heavily weighted toward Apple Silicon and a runtime called MLX. If you're on Windows with an NVIDIA GPU or any GPUs, you might browse the dashboard and find almost nothing for your setup. The community hasn't shown up yet either. It's brand new, it's pretty new, with minimal public discussion. So if you get stuck, you're pretty much on your own. My take on WhatCanI.Run is, while it's the very good conceptual right idea, and I think it's gonna get only better from now on, but there's not enough data yet. If you're on Apple Silicon, you can browse the dashboard right now. You might find exactly what you need. However, if you're on anything else, you can bookmark it and maybe check back in 3 to 6 months, or possibly even less than that if it goes viral because of this video or whatever, right? And if you do run the benchmark, you're helping the next person. That's how this tool will get better. Now the part that I think is important is neither of these tools should make your decision for you. The metal detector beeps, the logbook has some notes in there, but you still have to dig yourself. And the workflow that you can probably do it on your own and it'll take 20 minutes or so. Step number 1 is run LLM Fit. Get your shortlist, look at the fit scores only, and ignore the speed numbers there. And step 2, cross-check quality. Remember, LLM Fit ranks by fit, not by how good a model is. So take your shortlist and check it against what the community actually recommends. You can simply go to Reddit and r/local LLAMA or Hugging Face Trending or the companion guide I made for this video. If nobody's talking about a model, you can just drop it from the list. And step 3, pick the top 2 or 3 models that pass in both check. Download them in a lemma. Step 4, run each one, ask it a few questions and time it yourself. See how it feels on your machine or use LLM Studio to see the tokens per second yourself. Step 5, if you're on Apple Silicon, go to WhatCanI.Run and see if someone with your exact chip has benchmark data for the model that you're trying to test. Use it as a sanity check though. That's it. The cost to build this workflow is literally 0, guys. So both tools are pretty much free. Ollama is free. Cost to run is probably 20 minutes of your time and a little bit of electricity bill. And those 20 minutes are worth more than both tools combined, I think, because you're testing on your machine with your hardware running your actual workload. So the lesson here is pretty much the tools can narrow the list, but you make the call. There's no calculator or dashboard, whatever. There's no GitHub store count that should replace the 20 minutes of your own testing, right? So before you go spend your own money on this one, you gotta do this to make sure if whatever you're trying to do makes perfect sense before you do that. This was a rather short video. If you want to see more of these, and you can just comment down below to tell me what you want to see next, because that is how our channel runs. You ask, I build, we all learn. See you in the next video.